roughly about 40 to 45. So I think about 43 probably questions. So let's discuss about chapter 14 and 15. So 14 is about the simple linear regression, right? Let me hide this one. So we have studied the simple linear regression. You have to know the definition, like what is a simple linear regression. So we usually have one dependent variable and one independent variable for a simple linear regression, right? So it's a simple picture of the relationship between the variables that emphasizes key features and regular patterns. So you guys need to know the definition of simple linear regression. We also have the equation of a simple linear regression, which is this: y equals to mx plus b, or sometimes also we write it as b plus mx. So m is the slope and x is your the independent and y is your dependent variable, right? So if you have watched the lecture videos for Professor Sands, it should be pretty clear. So let me actually write down the important things that you guys need to know. So the definition, okay, of simple linear regression, right? What is it?
Are you sharing your screen with us?
Yeah, I'm sharing your screen. Can't you see?
No.
Let me see.
Is this being recorded?
We cannot see it.
Okay. Yeah, let me see. Something happened with the. What's wrong with it?
Is there any way we can record this?
Yeah, I'm recording it. It will be on YouTube as well. So, and also I will share it on. Let me see. One second, guys. Okay. Yeah, it got unshared. Can you see the screen now? Hello?
Yes, I can see it now.
Okay. So yeah, I was talking about the simple linear regression, that you have to know that the definition, right? So you have to know what it is. And we usually have the form y equals to mx plus b, or you can also see this form, right? It's the same thing. So this is the slope, right? And x is your what? Independent variable, and y is your dependent variable. So in a simple linear regression, we usually have one independent variable and one dependent variable. So the dependent variable, always there is one. So that's about the simple linear regression, right? Also, if you have watched Professor Sands' videos, what happens if the slope is 0? What does it mean? So if the slope is 0, that means there is no relationship between y and x. So what do I mean by that is, let's say I write an equation like this: y equals to 5 plus 1x. Here the slope is 1, right? So that means for 1 unit change of x, y will increase by 1 unit. So it will increase by the slope amount. But if y equals to, let's say, 5 plus 0x, but usually we don't write 0x, we usually write it like this, right? So what does it mean? There is no relationship between x and y, right? So if the slope is 0, no relationship between x and y, or in other words, you can say no relationship between the independent variable and the dependent variable. So in the MCQ, if I ask what is the, if the slope is 0, what's the relationship between y and x? So there is no relationship. Is that clear? You guys there?
Yes.
Okay.
Yes, I understand that.
Okay. So what if the slope is positive? Okay. If the slope is positive, then there is a positive relationship between x and y. So let's look at this example. Here the slope is 0.5, right? So let me use the snapshot tool. Okay, let's put this equation. All right. No, not color balance. Yeah. So in this case, what's the slope of the like this line? Let's say I ignore this. Can anyone tell me what's the slope?
It's the it's one, I guess. If that's no, I think that's the y-intercept. Well, it's 1.
1 is the beta naught, right? But this is the slope. The
0.5.
yes. So slope is 0.5. So that means for 1 unit change in x. Okay, change. Let me denote it by this. How much the y would change?
0.5.
Yes. So y would change by 0.5.
Is this algebra? This is a lot like elementary algebra, but I don't know.
Yeah, you can say because we did it. Yeah, in terms of you guys have calculated slopes before, right? Uh, so and there was a review for this in her lectures. If it's negative, that means it will decrease by that amount, and that is a negative relationship. So if the equation was negative, so let's say y equals to, let me copy this equation, 8 minus 2x. So that means 1 unit change in x would result in how many units decrease in y?
Two negative units.
Yes.
Or -2. Whatever.
Would not change, but here it will decrease. Here it should increase, right? The change is actually increase. Here it will decrease by 2 units. Okay, some basic stuff basically. And I already said if the slope is 0, there is no relationship. Then I can give you guys like a curve. If the curve is something like this, we can fit a best fit line, right? So can we model these as a linear relationship or not?
It's a positive relationship.
Yeah, not only positive relationship, but actually we can plot the best fit line here, right? So you can actually plot it. How about this one? Here,
it's a negative relationship.
Yeah, because the slope is negative, and it's downward trend, right? So it's a negative relationship. That means if x increases, y would decrease. Okay, so we can plot this kind of graphs. How about this diagram? This diagram, there is no trend. So no trend means that basically no relationship between x and y because the slope is 0. Okay. Can we model this diagram with a linear relationship?
It looks like exponential growth. I don't know.
No, that means we cannot do linear relationship, right? Because it's not a straight line. It's like a curved line. So it's like a curved line, right? So we cannot plot a linear relationship. So this cannot be modeled as a regression, So it doesn't. Or I can say there is no linear relationship.
I don't mean to cut you off. May I ask one question, please?
Yes, sure.
So, will the only stuff you be going over be on a final, or will it be like a cumulative of everything of like things that you won't go over? Because I'm like a little confused.
No. See, chapter 14 and 15. So I will only cover the final stuff. It's not, the previous chapter is not going to be in the final exam, okay? It's only chapter 14 and 15. So I will only cover 14 and 15.
Okay, thank you.
Yeah, you are welcome. So is that clear, everyone? So this one we cannot like a plot with a, we cannot model with a linear relationship. What about this graph? This graph also we cannot do it, right? If because there is no trend. Okay, so these diagrams we cannot really plot, so no linear relationship as well. Okay, so if you guys have I'm sure you have watched all the chapter 14 and 15 videos, so again there is no relationship here. Now the other thing that I want to talk about is the difference between regression model and the estimated regression model. Okay, so for a regression model, if we look at this model, okay, let me, so this is actually the regression model for the population. Okay, so for the population you will always see that we have an epsilon here. Okay, so this is for the population parameters. What about the estimated regression equation? The estimated regression equation, if you notice, they will all have small capital like beta naught, beta 1, and in front of the y there is a hat, right? So it's a hat, y hat, right? It's something like this. And we don't have the epsilon for an estimated regression equation. So because epsilon is assumed to be 0. Okay, so if I say what's the estimated regression equation, your form should be something like this. Okay, for example, if you have like beta 0 values, like let's say beta 0 is 10, beta 1 is -5, so your estimated regression equation should be something like y hat equals to 10 minus 5x, because I have given you guys the values. Okay, so for this example, we did like the beta 0 and beta 1 was given, so you just plugged in the values there. Let's see. Okay, also like sometimes I can say that what if the x value is this, find the y value. So let's do this example, for example here. So what's, okay, can anyone tell me what is the independent variable here? This model, predicted cells.
Oh,
The independent variable, I want to ask what's the independent variable? I didn't ask.
it's this. I guess it would be the y intercept. I don't know.
It's
because
the x
the
intercept,
slope is
right?
changed for advertising.
So advertising is the independent variable here, right? Let's say IV. What is the dependent variable in this case? Predicted sales, right? Let's see, anyone asked any question? That's the slope. 4.51 is the slope, and slope is the so 4.51 is the slope. So if advertising changed by 1 unit, how many units would the predicted sales change by?
4.51, I'm guessing.
Yes. So it will change by the amount of the slope. So advertisement is increased by 1 unit, right? Predicted sales would increase by the slope amount, right? So it would increase by 4.5 units. So what is the interpretation of the slope? So you guys need to know that. So I just explained. It's in page 13 of chapter 14, part 1. And I can ask about the confidence interval as well. So if I say that, if I give you the confidence interval, you know that the beta 1 slope would lie between such and such value, right? So we have all done this in our the lectures that Professor Sands has given for chapter 14. So it should be pretty clear what's the interpretation of the slope. And the confidence interval will actually give the ranges. So the range that the value would lie from such and such value. And I have to give you the confidence interval if I ask you a question like this. All right? And here in this example, the slope is negative. So this is predicted satisfaction, which is dependent on temperature, right? So and let's say the temperature is 22 Fahrenheit. Then you plug in 22 in the formula. So you plug it here, then you get the predicted satisfaction. So that means higher the temperature, the lower the satisfaction, right? So this example, because it's negative, the slope is negative. So if the temperature is 0, you have higher satisfaction. I mean, the lower the value, the greater would be the satisfaction, just because the slope is negative in this case. Okay, interpretation of the slope. And if I ask interpret with 95 confidence interval for the population slope, and I give you the range, then you can say that this value lies between such and such. So the upper bound and the lower bound in this case. Okay. And the most important thing to note here is that you guys need this in your formula sheet. Actually, I would recommend you guys to print it out, although it will be given in the exam. Okay. So let me just copy this one. In the exam, I can actually these are the formulas, uh, but let's say yeah, I will give it a worked example. That would be actually better, I think, in that sense. So let me remove this. Yeah, this example. So everyone can see my screen, right?
Yes.
Okay. Okay, for example here, if I didn't give you this equation, right? Let's say I ask you guys, find the estimated regression equation. How will you find it? You first write the form y hat equals to beta 0 plus beta 1 x. This is for single linear regression, just one independent variable, right? So only one independent variable. So then because the beta 0 is this one, so I can write y hat equals to 67.4709, and beta 1 is positive 1.1151x, right? And what is x? X is hours. So if you write the full form, your score, predicted score, is dependent on this 4709. This is the beta 0 and 1151, and this is the hours of study you have put into your so the more hours you put, your average predicted score is going to go up. Okay, and you can get it all this information from the table, right? Beta 1 is here.
Excuse me, will there be a problem where we have to fill in this table?
Yes, that's a very good question. What I will do in the final exam, I'm telling you, let's say I remove this part, or actually like some of them will be missing. Let's say I don't give this, then I don't give this, right? And then the r square, let's say I don't put this as well, right? So for that you need the formulas. So the formulas are all that's why I said use the formula sheet. So for r square is SSR over SST, right? So r square is SSR over SST. So how do you find r square? We have the sum of square regression. We have the sum of square total. So you can easily find this. So this is 8845979 divided by, this is the SST, 1848.7896. So then you will get the r square. So if you use the calculator, you will see that the value is 0.4785. 4785. Okay. Similarly, you guys need to know this formula as well, right? SST equals to SSR plus SSE. Here, what is missing? Here we are missing SSE, right? If you look at the formula sheet, SSR is given, SST is given, SSE is missing. But we know the SST, so SST is 1848.7896. SSR we know 8845979, right? This is your SSR, this is SST. So then plus SSE. Then you can use some algebra, you will find the SSE value. So SSE value is 964.197, 964.1917. Got it? And how do you find the total? Total you can find using n minus 1. So 24 minus 1. This is number of observations. So n minus 1 is 23. Or you can just sum these two and you find this value. Okay. So, and I can also, let's say I don't give you this one. What is the mean square error formula? The mean square error is SE over degree of freedom, right? If you go to that formula sheet, degree of freedom of the regression. So that's P. So of that regression. So of that regression is 1. So it would be still same. So 8, 8, 4, 5, 9, 7, 9. So basically you guys have to know all these formulas. Okay, very important. Let me just highlight this. Maybe you have to take up to this point.
Sir,
Yes,
how do you can you explain the adjusted R square?
adjusted R square. Yes, adjusted R square. You just use this formula to calculate the adjusted R square. Okay, so the important formulas, all of these formulas you have to use. I will actually give a question on adjusted R square. Okay, and n should be given, and then the p minus 1. So you have to use these to find the adjusted R square. So let me explain why we use adjusted R square. Adjusted R square we only use for multiple linear regression case, right? Chapter 15. Do you know why we use it? Because for simple linear regression, the form is only beta 1x, right? This is chapter 14 style, like simple SLR. But chapter 15 is multiple linear regression. What is the difference between simple and multiple? Can anyone tell me what's the main difference? We have more independent variable, right? Beta 1x, beta 2x1, beta 2x2, plus maybe even more. So if you add more and more variables, what happens is that your R square increases. But this not necessarily it means that this R square is better. That's why we have to use the adjusted R square. Because you can say that, Professor, I can add 100 variables so that my R square will become close to 1. But does it mean that your regression is actually better? Not necessarily. Okay. So I will come to that when I am explaining chapter 15. Okay. So basically you guys need to know these formulas for our chapter 14. Okay. And also for chapter 15 this will be useful as well. Okay, let's go to the chapters. So that was chapter 14 part 1. I have already said, can we plot this? Why not? Because we don't see a linear pattern. Then if there is no linear pattern, we cannot model it with a linear relationship. Okay, actually I covered this in the first part. I did this example too. Okay. What about the hypothesis test? Whether they're statistically significant or not, right? So let's write this equation. Hours is dependent on what is this model about? Mindtap score with hours spent. Okay, so if I write down this model, something wrong. Why it's not going up? Oh, maybe now it will go up. Yep. So mind tap score, if I plot that model, is dependent on this is the intercept 67.4709. This is the intercept. This is beta 0 basically, right? Then beta 1x. So plus beta 1 is positive, so 1.1151x. And what is x? X is the hours. So you have, instead of writing x, you can write hours, right? And if I say test the slope whether it is statistically significant or not. So how do you know if it is statistically significant or not? We have to do a hypothesis test, right? Beta 0 is equal to 0. In the other case, we assume it's not equal to 0. Step 1, right? And how do you calculate the test statistic? See, the good thing is usually the p-value will be given. If the p-value is not given, at least I have to give you the t-statistics and the standard error. So you have to calculate using test statistic. If p is given, you can directly use p-value approach. So t-test statistic equals to, I will give it because in the exam you cannot calculate the and the standard error is 0.24 what's 82, right? So formula is so the beta 1 coefficient over the SB1. So this should be in your formula sheet as well, and the p-value is given, and the alpha significance level should also be given in the question. All right, so alpha significance question in this question was given to be 0.01. So what is our p-value? What is our total p-value? It's 0.02, right? So alpha significance level was given 0.01, and the p-value from our question we got that 0.002. So because our value is lower than the significance level, right? Our p-value is lower than the alpha, right? Our p-value was 0.0002. It's lower than 0.01. That means we reject the null, right? So we reject null. What does it mean? That means the alternative is true. So accept HA. So yeah, I can ask one question like this, like is it statistically significant? How do you know? You can check the p-value and compare it with the level of significance. So if it is less than alpha, we reject. So if we reject, that means the slope is statistically significant. And there is a statistical relationship between hours spent and the score in the population. Is that clear to everyone? So, hello?
What number was that? I'm gonna have to go back because mine froze for a moment. What practice problem was that in the notes?
So this is from your chapter 14, the ones that I uploaded. Let me see.
Okay.
Let me see. It should be in your page 23.
Okay, so handout 4. Okay.
Yeah, handout 4, and I actually uploaded in the canvas. You will see chapter 14, page 23. All right.
Thank you.
Yeah, you're welcome. So again, for confidence interval, I will give you guys a slope. So you guys have to find the range. So if I give you guys, actually I will give you the range. Sorry, if I give you the range, let's say, see here the ranges are given. So if I ask you what is the beta 1, 95% confidence. Okay, let's use this. There will be similar question, not exact, but not this. is the snapshot. Very easy exam. Actually, this exam very difficult to make any mistakes there, I think. If I say, yeah, what is the... So if the question would be something like this, okay? The structure of the question will be exactly like this. Okay, so let's just copy this question. So here I asked 99% confidence interval, right? Since we are doing regression, what is the 99% confidence interval, okay, for slope beta 1? So slope beta 1 means this is only one variable. So basically they are talking about this slope, right? So the 99 percentile is lower 99% and the upper 99%. So it will range from the slope beta 1 will range from what? 0.4155 to 1.8148, right? So it can be in between these 2 points. If I ask you what is the 95%, then which one should you choose? This one and this one, right? For 95%. This is with, this one is with 99% confidence, right? But if I ask 95, then your range would be different. So 95 would be 0.6004 to what? 1.6299 with 95% confidence interval. So read the question carefully, okay? Sometimes I might ask 99%, sometimes I might ask 95%. Okay, so read from the chart, and you know the slope of beta 1 is usually the first x variable, right? So the first x variable is like ours, and the coefficient is actually your slope. Okay, can you write this model? If I ask write the estimated regression equation, Delvan, you there?
Thank you. Well,
Yeah, what would be the estimated regression equation for this? And let me tell you the dependent variable here is score. Okay. So first you should write the y hat equals to beta 0 plus beta 1x, right? So dependent is score, right? Dependent variable, I told you it's the dependent variable is score. So this should be what? Score hat, right? What's beta 0 here? 1.1151, right? It got disconnected again. Yeah, you guys can see my screen, right? It got disconnected for a short while. You guys can see my screen, right?
yes.
Yeah, it clicked down for a moment, but yeah.
Yeah, it quit down for a moment. So if I write the equation, Delvan, you there, right? So this is not beta 0 is not 1.151. Beta 0 is which one? Beta 0 is this one, right? So beta 0, let me use a blue color. It's more... so if you write the equation, it will be score hat. What's beta 0? Beta 0 is 67.4709. And beta beta 1 is what? The slope. Slope is 1.1151, and x is hours, right? So instead of this, hours. So this should be the estimated regression equation. Is it clear, Delvan?
Yes.
Okay.
I have a question. So on the test, you don't want to see y equals whatever it is, and then with the x, you want to actually see the phrasing.
I want the real value. Like if I ask you estimated regression equation and I give you the values, then you have to put in the values there. Okay, but if I don't give you the values, then you give me this phrasing form. Okay, then it will be like this because I didn't give you the values. Then yeah, and if I say give me the regression equation, so regression equation would be y equals to beta 0. Then it's for the population, right? Beta 1 x and always an epsilon. So this is regression equation for population. Okay, then this you have to give epsilon, all right? So there is always an epsilon, the error term. For estimated regression equation, we don't usually have error term, right? We don't have. Do we? No. Is there error term? No. It's always this form. And yeah, I want you guys to put in the values and the variable names.
Okay. So you do want the variable names. That's what I was asking.
Yeah,
thank you.
I want the variable names too. Yep. So that was it. That one. Also, like what are like the residuals? So residuals are like you can read this one on handout number 4. Okay, there will be one question on the residual and a few more questions on residual analysis, which I will get back to you guys shortly. All right. Yeah, I can ask what's R square. You need to know the formula, right? I can ask what is the standard error. This is root of mean square error. So basically the last page is very important for the regression output table. Okay. So yeah, I can ask you what's a standard error. Standard error is root of MSE. So if you have done the worksheets and watched Professor San's lecture videos, chapter 14 should be straightforward. Okay, it's not going to be that difficult. Let's do the chapter 15. So chapter 15, I will ask what is residual analysis, right? It's the examination of residual plots to see if any of the things are violated or not. So these are the 4 conditions that should not be violated, right? Actually, see the expected value of the epsilon should be 0. It should have constant variance. Okay, these are all the conditions that we must fulfill. Variance is constant, mean error is 0, then the epsilon values are independent and they are normally distributed. So these points are really important. Okay, otherwise your equation will be violated. So what it is, okay, it's basically examination of your residual plots. Okay, and to see if all the conditions are met or not. All right, so that's very important. I might ask, is this residual plot good? Then you can say, yeah, if it is good because both have equal number of values above the x-axis and the below the x-axis, right? Basically, this proves that the mean is 0. Okay, the epsilon error term mean is 0. Okay, so this diagram may come up in the exam. What about this one? This does not have a constant variance, right? Because here the variance is less, here the variance is large. But what is our assumption? The variance should be constant. Here some are like small variance, here is like big variance, right? So it violates assumption number 2. So this is not a good plot, right? How about this one? This one, see, this is if you see, assumption 1 is violated. It is not center, the mean is not 0 because it's heavily skewed towards the right. Like some of the residual plots are towards the right? It's more skewed, like the mean should be 0. Equal number of values should be here. Then assumption 3 is violated in this case because they are not independent, okay, in this case. There seems to be some kind of correlation between the plots. Okay, and one more thing I would ask is like within 2 standard deviations, most of your values would center around the like 95% would be centered around there. Okay, this is another characteristic of the residual plots. Okay, some of you will write -1 to 1, but that's not true. It is within 2 standard deviations, not within 1 standard deviation. Okay, don't make silly mistakes like this in the exam. Okay, so there could be like a multiple choice based on this. Then chapter 15. Okay, so I can ask the definition for multiple regression. So you have to write definition for multiple regression, right? What is this? Can anyone tell me what is the main difference between multiple regression and simple linear regression? Here there is one dependent variable and more than one independent variable, right? More than one independent variable. Because multiple linear regression is the form is something like this: beta 0 plus beta 1 x plus beta 2 x1 beta 2 x2. It could be even more. If you want to put more, it could be more, and then the error term, right? So like see here, how many independent variables are here in this example? Hello, you guys there?
Three?
Yes, there are 3 independent, x1 x2 x3. So there are 3 independent variables. Yes, yeah, good, Tyler. Yeah. And so there is one more thing for a multiple linear regression. Since there are 3, let's write a equation. Let's say your overall grade in the class, okay, this is just an example, is equals to 10 plus beta 1. Instead of beta 1, let's say do like 1.5 study time plus let's say if you study more, your grade will improve. Then your homework, let's say 2.0 homework completion, and let's say 0.5 attendance. Okay, so if I say that interpret the coefficient of study time, how would you interpret it? 1 unit change in study time would increase what? Grade by 1.5 units provided other independent variables are constant. Independent variables such as homework and attendance are held constant. It is important to keep the others constant. Otherwise, if they are not constant, then the grade will be impacted in a different manner. Okay. So if I say interpret the slope beta 1, here beta 1 is the study time, right? Because it's the first coefficient. So that means 1 unit change in study time would increase the grade by 1.5 units, provided that the other variables are held constant. Okay, that's an important criteria you need to fulfill. So again in chapter 15 I can ask write the estimated regression equation. You have to use the beta 1, beta 2, beta 0 and then you plug it in here. You can write this model, right? And then someone asked, who was it asked me that should I write the variable names or not?
That was me, Tiffany.
Oh, Tiffany, right. So yeah, you have to write the variable name. So what is x1? X1 is the TV advertisement. So you have to write it here. Print advertising is the x2. So you have to write the full form. Okay. So it's very similar to chapter 14. And in the exam, I'm going to erase some of this. You have to fill in the rest. Okay. So yeah, you will definitely get this question for sure. Okay, it's kind of I'm giving out the question in the exam, but you guys will actually, let me just copy this one. Oops, what happened? Yeah, so Tiffany and the rest, you guys would get something like this in the final exam. All right, so let me. And what I will do is like I will erase some of this. Let's say I didn't give you actually the whole thing I should have copied. Maybe minimize a little. Yeah, use the zoom tool. Snap it here. Yes. So yeah, let's say I don't give you R square. Let's say I didn't give you MSE. MSR basically the other one. Let's say I didn't give you one of these. Let's say now I don't give you the sum square total. I can also not give you the adjusted R square. Okay. So, and I can ask, write down the estimated regression equation. Okay. Let's say write it down. So, if you, let's say, let me erase this one as well, predicted revenue. So you will be able to fill this, the estimated regression equation, right? So it's easy. It's like y hat is your revenue, right? So in this question, y hat is the revenue. Beta 0 is your 87.0304. Beta 1 is the second one. So this intercept is TV advertisement. So it's 1.9365. So this is the beta 1, right? And I write TV advertisement. Okay, plus beta 2 is 0.5980 plus not plus what is this one? Print advertising. And then in an estimated regression equation, we don't actually write the epsilon error term because it's an estimate, right? So this is the full form. And for finding these formulas, I recommend you guys to print the regression output of chapter 14. So where is the formula sheet? Yeah, the chapter 14 regression output, the same one. Make sure you print this one out. Okay, these formulas will be really useful for you. Similarly, you can do the null hypothesis and alternative hypothesis. It's similar, pretty similar, and the p-value. So always compare your p-value. So where will you get the p-value? Let's say I want you to ask, let's say I ask, is print advertisement significant? Is print advertisement significant? And I give you the level of significance is 0.05. So Tiffany, is it significant?
I want to say yes.
How do you decide it is significant?
Oh no, yep, for the p-value.
Yes.
So no.
No, you are correct, because our p-value is what? 0.00244. Our p-value is less than alpha, right? Yes, it is less than 0.05 because our alpha is 0.05, and yeah, so we reject H naught because print advertisement is beta 2, right? So you assume beta 2 is 0 and the alternate was not 0. So since we reject the null, right, this is your hypothesis test, except HA, that means it is statistically significant. Yes, it is different from 0. So it is statistically significant. Okay, by the way, in the exam, if I ask you to write the values in 4 decimal place, you should write it in 4 decimal place, okay? Don't put the whole thing or just 2 decimal place. If you are lazy, you put 2 decimal place. But I asked in the question, fill the values with 4 decimal place. Then you have to fill it with 4 decimal. If I tell you keep the number in whole number means the n has to be in whole number, right? N's cannot be decimal or number of observation has to be left in whole numbers. Then leave it as whole numbers. Don't write 15.000 or 4 decimal. You should keep it as whole number. Okay, just to avoid some silly mistakes. It will be written in the question clearly. Leave it as whole number, leave it as 4 decimal, or leave it as 2 decimal. Okay, we are almost towards our end. Also, for multiple linear regression, there is something called joint significance, right? The F test. So let's look at our here. Who should I ask? Let me just ask anyone who is volunteer. Let me ask Hillary. Is it jointly significant?
Yes.
How do you decide it's jointly significant?
The p-value.
P-value from where? The F test, right?
Yes.
Yes. So yeah, you look at your F test, then you look at the p-value of F test. F test is very small. It's like 1.63 into 10 to the power negative 8. So this value is really small, and let's say I give you the level of significance 0.05. Of course, our value is less than 0.05, right? So it is jointly significant. Right? So I can ask that the joint significance as well. Okay, so it's open-ended. Thank you, Hillary. Thank you for answering. So yeah, we can ask the F-test one as well. Another thing is, let's say our weekly revenue is given in thousands. Then you have to convert it into thousands by dividing it by 1000. So there could be one question like this. Okay, be careful if the weekly revenue is given in thousands or given in real value or something like that. So you have to divide it by thousands, then you have to plug in into your value. Okay, like let's look at this example. Okay, just yeah, I'm doing more detailed this semester compared to previous semester. I didn't actually work out through the problems. I just assumed. So yeah, let me ask who is here. Tyler already answered. Tiffany answered. Hala, are you there?
Yeah.
Okay, so let's say I give you this model, right? And I ask you that this model, let's say this is the, let's look at this question. This is revenue is dependent on TV advertisement and print advertisement, right? So revenue equals to 87.0304 plus TV advertisement and 0.5980, let's say print advertisement. Okay, and I give you that x1 equals to like 37,500, and instead of 37,500, let me say x1 is 3,000 and x2 equals to, let's say, 2,000. And I say that the TV advertisement is given in thousands and print advertisements given in thousands. So how would you plug in the equation?
Multiply it.
Multiply it, or you plug in that value, right?
Yeah.
But if it is given in thousands, you have to convert this value into thousands. So then you have to divide it by 1000. What would be your x1 in this case? 3. And x2 you have to divide it by thousands, right? 2.
Yeah.
So you have to do like 1.9365. What should be TV advertisement in this case?
3.
3, not 3000. Okay, don't make make this mistake. Some students will plug it 3000 here because I have mentioned that these TV advertisements are given in thousands. Okay, that's how you will find the revenue. So so be careful if the question is mentioned that the TV advertisement here is given in thousands or the print advertisements are given in thousands. See, that's what they did. They converted into thousands and then plugged in. All right.
Okay, thank you.
You're welcome. Yeah, pretty much it. That's it. Okay, and yeah, I covered these parts as well. Okay, then model comparison. In this example, see, model 1 has a higher R square, right? And model 2 has a lower R square. So this is the adjusted R square. Someone asked me about the adjusted R square. Who was that person? Was it Tyler or?
It was me, Ezekiel.
Oh, ZQ, yes. See, ZQ, here, which model has higher R square? If you just look at this data, we know r square higher means better, right? Usually that's what we think. But do we use which model should we choose from this example? See, the model 1 has 3 independent variables. Model 2 has 2 independent variables. We, of course, I said more independent variables, the r square will be generally be higher, right? And we see that, yeah, r square is higher. What is r square? R square is basically the variation of x, the change in variation in x being explained by the change in variation in y, right? Or the change of the variation of the independent variable that is being explained by y, right? But yeah, r square is higher for model 1, but if we look at the adjusted r square, in the adjusted r square we actually see that model 2 has a higher r square. So not necessarily if we have a higher r square we should choose model 1, because the adjusted r square is suggesting that model 2 is actually better. Okay, so there could be question like this in the exam, like I can give you like an exam like this, or the one that has the lowest standard error. So either the adjusted r square has to be bigger, adjusted r square bigger, or the lowest standard error. So lowest standard error is this one. Someone messaged. Let me see.
Recording in progress.
What did I do?
Recording stopped.
Yeah, Tyler. Yeah, that's good. So we either have the higher adjusted r square or the lower standard error. If this is true, then we choose that model. Okay, that model would be better. Okay, so that's pretty much it. So that's like 40 questions will be there, 40 to 43 questions will be there. I won't ask you to find the adjusted r square, okay? It's too much work. Probably I will give the adjusted r square value. Then depending on that, you will know which model is better or not. So that's what we do. When we run regressions, when I was an undergrad student, I thought that, oh, I should add more independent variable, then I will have bigger r square. But when I added more independent variable, my adjusted r square sometimes said that it's not necessarily good to just randomly add more variables in the regression. You have to look at adjusted r square, you have to look at the standard error as well. Okay, so that's about the review for the final. Wish you guys all the best. And do you guys have any other question before I end the recording?
No.
Okay, so all the best. Keep safe and get vaccinated soon. Wednesday has already started the vaccination. I will probably start my vaccination maybe after the end of the semester. Okay, so yeah, have a good week, study and take the exam, and feel free to email me if you have any other questions. Okay, so thank you guys.
Thank you.
Yeah, have a good semester. Bye bye.
Bye-bye.